Hi everybody, this is Mrs. Ellsworth. We're going to start with atomic mass and also molar mass. Okay, so to find atomic mass, let's take out our periodic tables and let's look for aluminum. Okay, so the atomic mass is looking for the mass of one atom. Yes, 26, except for it's bigger than that. 26.981. Let me keep going there. 538. Okay, and this is an atomic mass units. AMU. Okay, so that's an atomic mass unit. Maybe I should write that out too. Okay, so there's one more thing here too. If we would go and do like carbon monoxide, so carbon monoxide, if you remember right, has got an oxygen on it and also a carbon on it. Okay, so a CO is its formula, and so it's got a carbon and an oxygen on it. And so the carbon, if you go and look up its atomic mass, is going to be 12.0107 AMUs. And then we can also add an oxygen to it. And that'd be 15. Look on your atomic number, look on your atomic mass on your periodic table, 9994. Yes. Okay, and then we'll go and get our calculators and we'll add that up. I'm going to pause it here. Okay, and so when I add that up, I got 28.0101. And now these are also in atomic mass units too, AMU. And because that is the mass that it takes for just one of these molecules right here, one molecule. Okay, it's the one molecule's mass. Okay, so really all you're doing is that you are just adding up whatever they are. Now, if they ask for nitrogen, then you'd have to do, because it's diatomic, you'd have to do 2 nitrogens. You'd have to do, it'd be around 28. It's 14 plus 14. And I just did really round numbers there. Okay, so this is the atomic mass units we just talked about. And again, this is the mass of one atom or else one compound. Okay, so now we're going to talk about the second one, molar mass. Okay, so this is different, and yet it's not. Okay, so molar mass. We haven't talked about what a mole is yet, but there's no way that we can measure one atomic mass unit. There's no way that we can measure that. So we have to start figuring out some kind of special way of getting our information from that periodic table and being able to use it with grams. Okay, because that's what we can measure, and grams are all small amount of grams, but I mean, it has to be a precise way. And so what we do is that we find the mass of 1 mole. Okay, so this is the mass of 1 mole, so it's mass in grams. I made that look like it's one word, but it's mass in grams of 1 mole. And that's a unit that we use. It could be like dozen. You could say a dozen eggs, a dozen people, a dozen cars. Okay, they've all got different masses, don't they? And so it's the same exact way on the periodic table. This is 1 mole of carbon, 1 mole of oxygen, 1 mole of hydrogen, and they all have different masses because you can see it on the periodic table. So this is 1 mole of a pure substance. Oops, TANCE. Okay, so this right here could be, the pure substance could be ionic compounds. Remember those ones start with metals? Okay, it could be molecules. And molecules are all covalent compounds. Do you need to write that down also, that molecules are covalent? Okay, or else it could be of atoms. Those are all pure substances. So it's pretty nice to do this. So like if I was going to go and find the mass of 1 mole of aluminum. Okay, so here's my clump of aluminum. 1 mole. Here's the exciting part. Oh, by the way, when you abbreviate moles, all you do is take off the E. That's it. Molecules and all those other things. It seems like such a thing. It just seems sad. Okay, so if I would go and find the mass of 1 mole of aluminum, here's the exciting part. It is going to be 26.981538 grams. Do you see the relationship there? This is the same exact thing, but 1 mole weighs that many grams, and then 1 atom weighs this many AMUs. So they're all related here by that. So you're doing the same exact thing, but when you're looking for formula mass, this right here is called formula mass. When you're looking for formula mass, because that's the mass of a formula, or the mass of an atom, you put AMU. Everything else is molar mass, grams. Okay, so then 1 mole of CO, what do you think that would be? Yeah, 20. Oh, I suppose I better put that in a container because that would fly away. 28.01. Oops. 0.01, and this would be grams. So it's the same exact way to do it. And so we've got a worksheet that we're going to work on, and I'm going to help you with a couple of them. And so let me pass it out, and I'll get back to this. I'm going to pause. Okay, so on this worksheet here, this atomic mass unit versus grams, notice that the whole front side asks for the atomic mass, atomic mass, atomic mass, formula mass, atomic mass. So the whole front side is actually going to be AMU. Okay, so that makes it pretty nifty right there. The back side, though, will ask for the molar mass, which is all going to be grams. Okay, but we're doing the same exact function for everything. So let's go ahead and look at number 1. Number 1 is asking for the atomic mass of zinc. Okay, so zinc is going to be 65.409, and we just have to know what unit, and it is AMU. You meant that. You meant that. Okay, let's look at number 2. Is C, oh, this one's going to be a tough one, CH2Cl2. So I'm going to go, are you okay? I'm going to go and add up 1 carbon. Okay, there's my 1 carbon. I have got 1 carbon here. Okay, and I'm going to, oopsie, I'm going to add it to 2 hydrogens. (794) here. Okay, and then I'm going to add that to 2 chlorines. Why do I keep doing that? Okay, plus 2. See, there's 2 chlorines. Look, look, look. Oh, 2 times. Thank you. Three. Okay, so let's go and add that up. We had a question in the class, where did we get these numbers right here, and that they are from the little red number on the periodic table. Good point. And why is there 2 times this? That's because of this. And why is there 2 times the 35.453? Because there's 2 chlorines. So we need to have 2 of them in our formula mass, because you got to count all 5 of those atoms. So we got 84.93258, and you've got to go all the way out. And this right here is for the formula mass, so that means it's an AMU. Okay? Okay. So then we'll go ahead and flip the page, and let's do that evil one on number 11 together. Okay, so that's going to be CH3 and NH2. Okay, and I'm noticing right away on here I've got 1 carbon and I've got 5 hydrogens. So I'm just going to rewrite this for myself here so that I are set up for a better success here. So 1 carbon is 12.0107. Okay, and 1 hydrogen is this 1.00794, but we got times that by 5 because there's 5 of them. So times 1.00794. Okay, and then there's just 1 nitrogen on here. That's nice. So that's going to be a 14.0067. Okay, so take a moment and calculate that. Okay, so we got 31.0571, and this side asks for the molar mass, and all molar mass is always measured in grams. So it's the same exact idea on both sides of the sheets except for worrying about those units. The front side is all atomic mass and formula mass, so that's going to be all in AMU. The back side, every problem, no, it's not. 15 and 20 are different, so watch out. Okay. Any diatomic I gotta do too. So that's a good question because number 3 sounds like a diatomic to me. Okay, we are going to skip a couple though. I'm going to have you skip 8, 9, and 10. Okay, so skip 8, 9, and 10. And how about 13, 14, and 15? Okay. I gave you some free points by giving you the answers for 1 and 2. Okay, I will see you tomorrow. Bye-bye.